out like a sheet of paper just to take a couple notes here. I don't know how much Mr. Mass told you, but we're just going to be going over trig, which is chapter 13. We're just going to start off with the basics today. He's going to review with you a little bit Wednesday. Today we're going to be going over right triangle trig. This is probably the easiest of your trig identities. The easiest way to see if it is a right triangle is to identify it by the square in the corner, which signifies that it has a 90-degree angle. This is a classic example of what you'll see in most of your problems for right triangle trig. Your most common identities for these will be sine, cosine, and tangent. Have any of you guys heard of these before? Okay. So we're just going to be going over the basics of them. So sine is going to be sine of theta. Theta is this little symbol. It's going to be kind of like your x in this chapter. It's unknown. You're going to try and solve for it. Sine is the opposite side over the hypotenuse of the angle. Same with cosine. It's your adjacent side to theta over hypotenuse. And tangent is your sine over cosine. Now, a really easy way to remember this, if you guys have heard of this before, there was an Indian named SOHCAHTOA. This is a really easy way to remember how these work. Sine, her name is spelled out SOHCAHTOA. Each enunciation is sine, which is your opposite over hypotenuse, cosine, which is your adjacent over hypotenuse, and your tangent, which is opposite over adjacent. So now these are going to be some trickier identities. You'll use them in this chapter. You won't probably use them as much in the future, but they are the inverses of the previous trig identities. They are cosine or cosecant, secant, and cotangent. Basically, they're just the reciprocal of the previous ones. The easiest way to remember which one is the reciprocal is that C always goes to S. You never have, like, the cosecant will be the reciprocal of sine, and secant will be the reciprocal of cosine. So you always have a C and an S together. You never have like a C and a C or an S and an S. So your cosecant will be your 1 over sine, which is just the reciprocal of it, which is hypotenuse over opposite. Secant is 1 over cosine, which is hypotenuse over adjacent. Same with cotangent. It's 1 over tangent, which is, instead of sine over cosine, it's cosine over sine. And that is adjacent over opposite. Okay, so we're going to go over an example real quick. So in this example, I really want you guys to focus on at least the first 3, just trying to solve for them. And we're going to call this corner over here, this is going to be your theta over here. So if you want to write that down in your notes, that this is going to be your theta. And I just want you guys to take a couple minutes, try at least to solve for the first 3, but we'll go over them in a second.
Leave them as a fraction.
Yeah, don't solve for the decimal point, leave them as a fraction.
And leave them as a mixed fraction, do not do a mixed number. You're not solving for theta yet. She just wants you to write down what the sine of theta equals. So in your notes, you had sine of theta was what?
I write down because I didn't know it's SOHCAHTOA.
Okay, so you can use SOHCAHTOA. What's the SOH stand for? Yeah. So if this is your theta.
Oh, so I'm just writing it?
Yeah, so what's your opposite?
3,
Over?
5.
Yeah, that's what I got right down.
Wait, so, I don't know how
Sine for sine, wouldn't it just be
Or if this is your angle, which one's opposite?
I don't understand.
Why that is your angle, your point? Which side is opposite of that angle? Okay, so that's 3, and then what's the hypotenuse? 5. So that's it. So when you have sine is opposite of hypotenuse. That's all we're doing right now. Just write the theta in there if you want to, but and then eventually you'll find what the angle
So
is. But
what's the, I don't understand that.
that's the inverse.
So it's just the opposite of one of these?
Yeah, that's what you have written up down here. Opposite. Yeah.
Uh,
So basically, you just flip whatever the sign is.
alright, got you.
Yeah, exactly. The adjacent is one that's touching it, that's not the hypotenuse. Don't make it this direction. Make it proper. You wrote that as an example. Just write it in the proper form. Yeah, I'll make it easier to flip it. Like a tangent. Oh, wait, yeah, did I know it gets nine? No, okay, it's just nine, that's fine. What kind of adjacent of a hypotenuse? You did the same thing I did. She didn't write them down.
I wrote them down in a different order,
Yeah.
sorry, I just did like,
Here's your first 3, right here, 1, 2, 3, and then these would be the 3 that reflect. So, yeah, cosecant here would be, it is a flip, yeah, so that one you did right, okay. Secant is a flip of cosine. And cosine, right? What's cosine? SOHCAHTOA. Yeah, up here, cosine. Yeah. And then your secant will be the flip to that. Yeah, right, so, good. And then tangent, flip of, yeah, the tangent's flip of tangent, okay.
okay, so I'm just gonna call on you guys, I don't really know names, so probably gonna call you out by like what your shirt says. So can you and the leopard buddy, what's your name? Danielle, can you tell me what sine of theta is?
3/5.
Okay, how many of you got that answer? Okay, how many of you did not, or got something different? Okay, what did you get?
Oh, I had 3/4.
You had 3/4? Okay, that is actually your tangent. Okay, Ohio State, what's your name? Lexi. Okay, can you tell me what cosine of theta is? 4/5, good. Who else got that? Who did not get that? Good. Okay, now who wants to be brave and volunteer to tell me what tangent is? Yeah.
I got 3/4.
Good. So that's basically you just taking your sine and your cosine and dividing them, which cancels off 5, and you get 3/4. Now, who can tell me what secant of theta is? Yes, what is it?
5/4.
Yes. Sorry, I had to think about that for a second. It's basically just the reciprocal of cosine. So if you solve for the first 3, the second 3 should be way more easy. You are just flipping those numbers right around. So, polar bear, what is your name?
James.
James, can you tell me what cosecant is?
That is 5/4.
5/3.
5/3. Your cosecant is the reciprocal of your sine. So you're close, just I think you might have flipped those two. So who else got 5/3? Who got something different? Who wants to own up to it? Okay, and the last one is going to be your cotangent, which is just the reciprocal of tangent. Who wants to give that a try? Yes. 4/3? Yes, that's right. Okay, who has any questions about this? Still not getting it? Look, it seemed like everyone really got it. I'm gonna start a second example. If we don't have time, that's fine. I'm just gonna write it up here on the board. Okay. So this is your new triangle. Again, you can tell it's a right triangle by the square in the corner. You guys can just solve for sine, cosine, and tangent, and then we'll go over that real quick.
Does that say,
That's radical.
okay.
This is radical too, sorry. This is an example of a 45, 45, 90 triangle. You'll be going over like two basic types, which is 30, 60, 90, and 45, 45, 90. You guys can leave it as radical too. You don't have to solve for the decimal point of that.
Well, she had to do that, but yeah. You did not put the.
Okay, do we want to go over this real quick? We have like 2 seconds.
Yeah,
So,
you have like 4 minutes.
oh, you?
Yeah.
35.
Yeah.
So who wants to be brave and volunteer to just tell me one of the answers? Really?
Sine is 1/2.
Yes.
Cosine is 1/radical 2.
Okay. And who wants to tell me tangent?
1/1.
1/1, yes. And that simplifies to
1.
1, yes. Okay. So this one is a really easy one. It's a 45, 45, 90. So that means 2 of your sides are going to be equal. So it's really easy. Basically, your sine is going to equal your cosine. So if you guys can go through and just solve for your cosecant, secant, and cotangent. These should be really easy